Okay, good afternoon, everyone. So let's start our lecture today in the partial differential equations. Okay, I think in our last lecture we have finished our type number 1 and 2. That so we are in the type 3 in the middle of the lecture. We have stopped that lecture. So I will continue from there. You can hear me now? Can you all hear me well? Okay, yeah, thank you. So I'll do some recap of our type number 3, okay, which is using the multipliers, okay. So if you are having some, if we start from the auxiliary equations of dx over p, is equal, our actual equation is capital PP plus QQ is equal to R. Then we have the auxiliary equations. This is Q is equal to dz over R. So in that sense, in some situation of type number 3, okay, type number 3, we have to choose the multipliers which make the denominator of which is equal to 0. So I'll start from the example, okay. I'll choose the example I gave you, okay. First of all, for example, our mz ny is equal to p plus nx minus lzq, which is equal to ly minus mx. So we have to know this is in the form of quasi linear equation of pp. This one is our q, capital Q. This is our r. Okay. So we can use our Lagrange's auxiliary equations. Okay. Solutions. You can the Lagrange's auxiliary equation of the given equation is, okay. So what is that? So dx over whatever our p. So this will be mz minus ny, which is equal to dy over nx minus lz, which is equal to dz over ly minus mx. Okay. Then we have to choose the multipliers which can make our denominator zeros. Okay. So first of all, let's have the so right, choosing x comma y comma z as first of all. Okay. So I have explained this process. So I'm just showing the answers. Okay. Choosing x, y, z as multipliers. Okay. Multipliers for each fraction, for each fractions. So I'm gonna take this equation as 1. Okay. Fractions, and then let's take this fraction as number 2. Okay. Fraction number 2. So what is that idea is you have to multiply this first fraction as x and next one by y, and then third one by z. And then, so if you wanted to have the denominator equal to 0, if you multiply by x, I mean numerator as well as denominator plus this one, you will have, which is equal to, so I'll erase this window. So please write down also if you need anything, or otherwise take a screenshot if it is okay, right? So I will go to the next window, okay, for the continuation. So first I have choose x, y, z as multipliers for the fractions x, y, number 2. Okay, now I'll continue. So if I multiply, I will have x x dx, okay, and y dy plus z dz. Similarly, if I multiply my, the denominator mz minus ny plus y times nx minus lz plus z times ly minus mx, okay. So what you'll get, which is equal to, so we don't have anything, no difference between in the numerator. So y dy plus z dz. So what will happen to the numerator? See, this is like mxz minus mxy, nxy, okay, sorry, mxy plus this one nxy again. So this will be cancel out minus lyz, okay. So this one lyz again. So minus plus. So it will be cancel out. This one mxz. So you can see this one, this one. So that's why we have choose xyz according to get the denominator as equal to 0. Okay. So now we have 0. So therefore, so write down, therefore, we have x dx plus y dy plus z dz, because what is happening is dz, okay. What is happening is, so which all are equal now. For example, our fraction dx over p, which is equal to dy over q, dz over r, all are we are equating for a constant no? One thing, okay. Similarly, this one also we are equating, okay. So this one. So when you are getting, you will have this one. If the denominator equal to 0, so we, in the notes also I have gave you. If it is the denominator 0, this numerator should be equal to the 0. Okay. So in that sense, then you can either multiply each term by 2 and take the integral, or otherwise you can take integration. Okay. Integrating this equation, you will get our C1 equation. So for example, you can take like x squared by 2 plus y squared by 2, z squared by 2. As you know, so I'm going to take my C1 also by 2. So as you know, what is happening is you are integrating each term. Okay. So x times dx will be x squared by 2. Y times dy will be y squared by 2. So I can have this one simplified. X squared plus y squared plus c squared is C1. This is my pi. Okay, I have got one solutions. So how to find the second solution? Because our general solution should be g pi comma chi, which is equal to 0. So I have found this one. I need to find this one. So choose another multiplier which can make this denominator equal to 0. Okay, rather different than this one. So here you have to use some logics to get our denominator equal to 0. Okay. So in this example, I will tell you anyhow. In the example question, you just try yourself. Okay. You just try which multiplier can be. Okay. Sometime maybe 1, 1, 1. Sometime maybe x, y, z. Sometime maybe possible one. Okay. 1 over x, 1 over y, 1 over z. Or 0, 1, 1. 0, 1, minus 1, something like that. Okay, you choose that, and so that's how the question will come. Okay, according to the question, you choose the multipliers. Okay, so which can make our denominator which is equal to 0. Okay, now I can choose one more denominator. So you can see we have choose x, y, z, which can make. Then let's see. We don't have this one. No, in our original equation is x, it has mz minus ny. Other one, nx minus lz. Other one is ly minus mz. So how you can make this one again 0? One possibility we have seen and we got the answer. We need to find another chino. So which can make it 0? So can you think about it? So let's see. For example, we have LMN also. So let's choose one according to that. So here you can see mz minus ly. So I'm going to choose L. Okay. Time. Let's say this one M there, L there. So M only missing. So M. Here I have L, M. So I'm going to choose M. See whether it is also 0. L, M, Z. Yeah. Yeah, L, M, Z here also. So it will be cancelled out. Okay. So our next multiply will be, write down, choose. So again choose L, comma, M, comma, N as multipliers. Okay. Each fraction of our, equation number 2. Okay. So it will be turn around that one. So shall I erase this window? Hope you are writing with me. If you are writing with me, I don't need to wait. Okay. So when I'm writing the answers also, you just write down or take the screenshot also. Okay, it will easy for you to study. Okay, I'm erasing this window again. Okay, so I'm choosing L, M, N as a multiplier. So my equation will be turned into, okay, L dx plus M dy. So I can choose L plus N dz. So the denominator will be L time mz minus ny plus m time nx minus lz plus n times ly minus mx. Okay. So see whether you can check the denominator, which should give you 0. Okay. So you can check. Okay. And then therefore you can get our numerator as 0 as well. Okay. And dz which is equal to 0. Then again, if you're integrating, what you'll get? So if you integrate each terms, okay, don't write like what I'm writing. You just write here. Okay. I'm just using my writing. Okay. If you use the integral of this one, what is LMX? Can you tell me the answer? What are the LM and L, M, and M? So is that when you are integrating, what will be the answer? Can you give the answer, please? Okay, what are the L, M, N now? Called what? What kind of is? Yes, good. Okay, good. So yeah. So we are taking LMN like a constant, isn't it? So it doesn't change anything in the integral. So it is like we can take the L out and integral of dx will be x. Similarly, other one, okay, my plus nz, which is equal to C2. I can take another C2, okay. So I got another equation. This is, I can take as a chi, okay. So therefore, my you can take this one, other equation as 3 and this equation as 4, okay. So therefore, from equation 3 and 4, okay, so write down the solution. The required general solution, the required general solution is phi comma chi, which is equal to 0. Therefore, g is equal to what is our early chi is equal to x square plus y square plus z square, comma this one will be Lx plus my plus nz, which is equal to 0. This is our final answer. Okay. This is how we solve this kind of multiply questions. Okay. Type number 3. Okay, I'll give some examples so you can try. Okay. try. So I'll erase this window. So write down some exercises you can try for yourself. Okay, for type 3. Yeah. That time x plus y of p, small p, plus z time x minus y of q is equal to x square plus y square. This is our first question. Try the second question. Okay, try this one. X times y minus z of p plus y times z minus x of q, which is equal to x minus y divided by xy. So you can try these two equation under the type number 3. Okay. Let me continue. Type number 4. Okay, there is one more similar one, but a little bit of difference. Okay, so you can put the heading. So I don't have the type things, but I will write you. So write with me. Okay, type number 4 to solving this kind of equations. Okay, type number 4 for solving auxiliary equations. Okay. Okay, for this, I'm going to write the notes and all, or something I may tell you. So you can write down, okay? Okay, give me a second. Okay, so type 4, so write down the thing, okay? Let P1, capital P1, Q1, and R1 be functions of x, y, and z, okay? Then by a well-known principle of algebra, each fraction of dx over p, dy over q, dz over r will be equal to p1 dx plus q1 dy plus r1 dz. So this is what we have done in the type number 3. Okay. So p1p plus q1q plus r1r. Okay. This is equation number 2. So this is our type number 2. So write down continuously. Suppose the numerator of 2 is exact differential of the denominator of 2. Suppose the numerator of 2 is exact differential of the denominator of 2, then 2 can be combined with the suitable suitable fraction in 1 to give an integral. So suppose the numerator of 2 is exact differential of the denominator. For example, let's say we have x squared here. Here we have 2x. So this one, then denominator's differential will be in the numerator. This kind of, okay. Combined with the suitable fraction 1 to give an integral. Okay, I will continue with the other window. So please write down or take a screenshot. Okay, now continue. However, in some problem, another set of multipliers P2, Q2 and R2 are chosen, that the fraction P2 dx plus Q2 dy plus R2 dz divided by P2p plus Q2q plus R2r, okay, is such that its numerator is exact differential of the, okay, denominator. I think I have told you different way. Earlier one, it's like this, x squared and 2x. Okay. This one, let's say we have, for example, what? Cos x. Here we have, here I have minus sign. Okay. Like that. So earlier one, numerator has the, denominator is the exact differential of numerator. Now the denominator, like that, the numerator is exact differential of the denominator. Okay. So numerator is the exact of denominator. So other way. Okay. All right. So in that case, write continuously. Fraction 2 and 3. So this is other one 2, this one 3 are then combined to give an integral. So we're gonna use both. In our type 3, we have seen both are in a different way. Okay. For one multiplier, we got another one we got. Now we are taking the two multipliers in two different way, but we are combining to get the integral. So write continuously. This method may be repeated in some problems to get another integral. Okay. So if you want one more integral to get the C2, we can combine these and get the other integral. So we can see the example, so it will be easy for you. Understand? Okay, let's do one example. So let's see what it is saying actually. Okay. So this type 3 and 4 may look like the same, okay? Everything like, for example, in type 1, 2, 3, all types are for the equation PP plus QQ is equal to R form, okay? So you have to know which type we can use to get which, okay? So in that way, let's do one example for type number 4. So y is plus z of p, which is equal to z plus x of q, which is equal to x plus y. Okay, let's say this is our example. Okay, this also look like chapter number type 3, but anyhow, we have a small difference. Okay, let's see how we can solve this. For example, yeah. First of all, write the Lagrange's auxiliary equation for equation 1 is, what is that? Dx over whatever the p, no? So you can write p, q, r, then you can substitute. Okay, so you have to know this is our capital P, this is our q, this will be our r. So y plus z, which is equal to dy over z plus x, which is equal to dz over x plus y. Okay, now let's choose some multipliers. Okay. Our meeting will be finished in 10 minutes, so join again. Okay. So first let's choose, okay, can you guess the, the multiplier, first multiplier? Let's take this one too. So which will make it 0? See, in this we don't have x. In this we have x, no y. Here x and y, they are z. But all are positive, no? So if you wanted to make vanish, it will be 0. You have to multiply by some negative also. Okay, okay. So I will, because this is our first example, I will give you the multiply. Okay, so choose 1 comma minus 1 comma 0 as multipliers. Okay, so what you'll get? So if you choose that is equal to 0, so this one is equal to 0, 0 times this one, this term will be 0, no? So we don't get this one, but this will be negative. So let's say g equal to dx minus dy divided by y plus z minus z plus x. So what is the answer? So it will be dx minus dy over z and z cancel out now, y minus x. Okay. So is that look like the form of any uh, that's what we see, no? The numerators differential derivative will be in the if it is numerator, this is numerator, this is denominator. So if the denominator looks like the derivative of the denominator looks like as a numerator, so first one. So look at this one, because since these are, okay, these are linear one, dx, dy, okay, this kind of equation we called as a linear, no? So it's like a term. We can write this one as a d of x comma y, okay? So for example, let's say x plus, oh, sorry. If it is x plus y, if you take the derivative, so d of x plus y, which is equal to what? Dx plus dy, no? So this is a linear one, okay, linear operations. So I can write this one also as d of x minus y. Here I have y minus x now, so I'm going to make it as a x minus y. So if I take minus out, I will get this one. So what do you think? So x minus y is my original denominator. Its derivative there, no, d of x minus y. So I got the things. This is my third equation. Okay. So keep it as it is and we will continue. Okay. So are you writing with me? I need to erase the window. So Please write with me and take the things quick as possible. Okay. Also take the screenshot so you can check your notes later. Okay. I'll continue. Okay. Now choose another multiply. Okay. Choose like this one, 0, 1, -1 as multipliers. Okay. Then what will happen? The x term will be gone. First term will be no. Second term, so you can see our fraction will be turned into dy minus dz divided by x z plus x minus x plus y. Is that correct? So I don't have to see. So is that correct? So this also I can write dy minus dz. If I am wrong, please let me know. Okay. So x and x cancel out. So z minus y. So similarly, you can take this one also. Y minus z divided by minus y minus z. Okay. Same there. Okay. All right. Okay, let's continue. So since we are choosing this one, let's I'll take as equation number 4. Okay. Since from our equation number 2, only we have derived our 3 and 4 now. Okay. So therefore everything are equal. The equation of 2, from that only we got 3, from that only we got 4. So from that we can conclude equation 3, which will equal to equation number 4. Okay. Since we are getting from one equal, equation number 2. So if you equate number 3 and 4, what you'll get? dy minus z over, okay, I'm writing this one first. Okay, let's write that one. Okay, x minus y. This will be x minus y minus now. This is equal to dy minus z divided by minus y minus z. So I can cancel out this y minus and minus. So see here, if by next step, if you integrating, okay, if you integrating, what is the integration of this one? For example, let's say I have cos x. Here I have minus sin x. What is the integration of this one? Can you tell me the answer? Or like this, for example, dx of x on our x. What is this? Derivative of x is what? Yeah, good. Derivative of, yeah, you got the idea, no? So this will be ln cos x. You can put the modulus or not. This will be ln x. Okay. So similarly, you can see this x minus y derivative there as a numerator. So you can put like ln x minus y. So this will be ln x minus y, which is equal to, what about the other side? So this will be d, no? Ln y minus z. So you have to choose one arbitrary constant also, no? So because everything are ln, I can choose ln c1 also. Okay. So if you take this one, this side, what will happen? Ln x minus y minus ln x y minus z will be, you can write as a x minus y divided by y minus z. Am I right? Yes. This is equal to ln c1. Therefore, what is the c1? C1 is equal to, you can cancel out the ln both sides. So x minus y divided by y minus z. So we have found one C1, one pi, okay? Pi equation, which respect to x, y, z, okay? X, y, z. Okay, from these two multiplier ideas, I got only pi. So still I need to get my chai. So these two multipliers not help me. So I need to go for another multiplier. Okay. So you have to think, if you get like this question, they may have the multipliers. Okay. Like this multiplier, see 0, 1 minus 1, 1, 1, 1, maybe sometime, or x, y, z. So far we have done 2 or 3 questions. You can see how they are asking the multiplier L, M, N. Okay, according to the question, it you are getting. Okay, earlier one also 1 minus 1, 0. Okay, so this kind of multipliers only. So you have to, when you are doing more questions, it will be you will use to that. Okay, you will find quick as possible. But if it is little bit hard also, you just think sometime and find the multipliers. Okay. Okay, I will erase this window. Please write down whatever you have left out. Okay, will erase. Okay. So let's continue to find our chai. Okay. So now choose. So we have choose 1 minus 1, 0. 1 multiplier. Other one 0, 1 minus 1. Is that? Yeah. Next one.